right. Hello. Afternoon, everyone. Welcome to a new year. It's 2022, but it's the same duo. It's James and I. Welcome to a whole new year of Composite Tech Talks, powered by Composites One and Iacme. We're super excited to have everyone joining us today, but we're going to give a little bit of time for attendees to slip in. So as you're joining us, go ahead and jump into the chat. Let us know where you're tuning in from today.
Hey Tyler, I'm tuning in from Fort Worth today. How about you? Where are you at today?
Same old spot. All right, so you're still in the same spot. I'm also still in Knoxville, Tennessee. So it looks like, and so we're also joined today by Scott Lewit, president of Structural Composites. Scott, where are you guys located? Where are you at today?
Yeah, we're located in Melbourne, Florida. Got you.
Sunny Melbourne, Florida. Awesome. I think a couple times in past episodes, I think I've seen some Melbourne, Australia attendees. So who knows?
On the weather, I think.
All right, awesome. Well, hey, I think we've given enough time, so we'll go ahead and jump right on into it. Like I said, welcome to Composites Tech Talks by Composites One and Iacme. Today, we've got an awesome guest, really exciting topic. We're joined by Scott Lewit, president of Structural Composites. We're going to be talking about new transportation applications for composites utilizing technology stair-stepping. Awesome corner of the industry that I'm really excited to hear about. So real quick, I'm going to hand it over to James. He's going to give a little bit of word to our featured partners today.
Yeah, so today's talk is brought to you by Composites One and Iacme, as Tyler mentioned. Also with Aerovac Composites One, Magna Venus Products, and the Closed Mold Alliance. And I'll give it back to Tyler to tell you a little bit about Iacme, the Composites Institute.
Thank you, James. And yes, super big thanks out to all the sponsors and partners. Without them, this would not be possible. So a little bit about Iacme. We are the Composites Institute. Our mission is to accelerate the development and adoption of innovative manufacturing technologies. Our goal is to spur the growth of low-cost, energy-efficient, advanced composites applications. Our collaborative work through public-private partnerships drives domestic production capacity, strengthens U.S. manufacturing competitiveness, and elevates job creation across the U.S. composites industry. I'll hand it over to James to talk a little bit about Composites One.
All right. Thanks, Tyler. Yeah, Composites One, we're the largest composite material distributor in North America with over 40,000 different products from 600 of the industry's best material suppliers. We have more than 45 stocking locations. A lot of those are actually AS 9120 certified with pre-preg freezer storage. And all those materials are delivered on our own fleet of trucks. We also have excellent technical support. By the way, I'm a part of that team, lead technical support manager. So we have I have 10 colleagues regionally dispersed throughout North America to help customers select materials and develop composite solutions using those 40,000 different products. And before we jump in to hear from Scott, we also wanted to mention we're after a 2-year hiatus, we're starting up our composite workshops again. So
Exciting.
With Iacme and Composites One, and we're going to be right next door to Scott down in Cocoa, Florida next week. So April 12th and 13th. There's still time to register for the workshop. Down at the lower right-hand portion of the screen, you can see the URL to register. There's no charge, and we'll actually be providing some meals. So come listen to some great content, see some great closed molding demos. You can also use the QR code at the bottom of the screen.
Yep.
So find out more at the URL, iacme.org/from space to sea.
Come hang out with James and I down in Florida. Get some good weather.
Yeah, and then just another quick note. So some of the presentations and sponsors of that workshop listed on the screen. We have A&P Technology. It's going to be at Eastern Florida State College. Another sponsor, Space Coast Consortium, Structural Composites, Matrix Composites, Polent, Chemtrend, Texonic. So just a whole host of companies. Come see their products and listen to what's new in the industry. So I know you all joined to, you didn't want to hear about all our sponsors, but I want to introduce Scott Lewit. He's the president and founder of Structural Composites and Composites. He has a BS and MS degrees from Florida Institute of Technology, although I understand you're not a native of Florida, Scott, but also he's an inventor on multiple composite patents, from preforms to co-cure technology, composite bridge decks, floor structures, and many more. Scott's been in the industry for over 35 years, and most people in the industry are friends with Scott and know Scott pretty well. So Scott, I'll go ahead and hand it over to you, and we'll hear about the technology stair-step.
Thanks, Tyler and James. Thanks a lot for hosting us today, and thanks everybody for joining. And really look forward to seeing everybody next week at Space Coast. There's just so much happening here at this part of the country. Having moved here, I came here to go to Florida Tech in 1980, and it was a sleepy little beachside town that you could get engineering and be on the beach, and it was kind of nice. Now it's just completely transformed into a just technology powerhouse here. So if you're coming down for the event, I encourage you to take an extra day or two and explore the area. We've got so much cooking from the aerospace guys in Blue Origin and SpaceX to the marine guys doing a lot, right up and down the board. So Melbourne's really a happening area. So look forward to seeing you next week.
I can't wait to get down there.
Yeah, look forward to having you guys, and we'll talk more about technology generation. Because we come out of the marine industry. Our core is boats. So a long time ago, we decided a lot of people were chasing aerospace, and there's a lot of competition, and it's really hard to break into, and the volumes were, hard to get. We always had a passion for marine and boats, and what kind of started our company was materials were coming out of the aerospace industry, particularly like knit fabrics in the 80s, and starting to migrate into the boating industry, and people just didn't know how to use it. So we started out filling that slot, getting rid of wood, chop, woven roving was how we built boats in the 70s, moving to sandwich and more advanced constructions. And that's kind of how we started this journey. But unlike the aerospace industry, the marine industry is in relative poverty. We don't have the kind of money, the research dollars, the large organizations that can do a lot of breakthrough technology. So we've come up with a way here to do technology development that I think a lot of companies might be interested in, from small companies to big companies. And it's a way to really leverage the resources this country offers. And so what I call this is technology stair-stepping. What I'd like to go through today is some of the steps, and for both, like I said, large and small businesses, you can tap these resources that our country makes available through the government. So you wouldn't believe it, but the government is actually sometimes here to help. And there's a tremendous amount of money being put into dedicated to small business innovative research that only small businesses could go after. I'm going to tell you about that. And for us, the marriage to marine was the close marriage was with the Navy. Sorry there. And so we did our journey with boats again, and came up with some neat technology, and had to try to take a new technology and get it commercialized. So with Prisma, which we invented in the 90s, we were able to commercialize it ourselves. This new invention called CoCure, I'll talk about, a lot more chemistry, a lot harder to just go do. And so it really needed supply chain engagement. And I'll talk about how the commercial market really helped pull that together. And we were able to make commercial products that eventually circled right back and helped the government. So it's a nice story of the government helping industry, which in turn helps the government. And that's really the mission of these programs, is to generate kind of game-changing technologies. So if you're looking for research funding, you know, there's a few places you could go. One is the DoD and the government side. And in particular, the DoD is a very good source of funding. As you look at other branches of the government, the budgets at DoD are by far the best. So we fund our defense well, and defense budgets, righteously so, are going to be going up next year. I'll turn this timer thing off. There we go. So that's one source. The other is commercial research, doing work for people, contract research. And then the last one is your own money, internal research and development. So those are your three pathways. And if you're a small business, this last one, the IRAD, that's the hard one, because it's hard to fund research, you know, and even the big guys, I don't think I've ever heard a company come to me and says, I'm overfunded in research. Everybody wants more. Okay, so, and we are the first to get cut when budgets get tight, and you know how that goes, right?
Right.
So when we go, let's just go into the Department of Defense. And so each of these Department of Defenses has what they call small business innovative research projects. I'm going to go into the Sbir and what is the Sbir. But these guys basically get taxed. All the branches of the government are getting taxed. A certain percent of their money has to go into the SBA, Small Business Administration. And since they're giving that money into the SBA, they obviously want something good for it. So what they do is they put all the stretch technologies, things that they are on their wish list. It's kind of like here when you hire interns. You know, they do the work that you don't have time to do. Okay, you're doing the same thing here, but here we're trying to develop some good groundbreaking technology. And in our case, we came in on the Navy on an SBIR. That'll be my case study to talk about, to make a better, tougher, lower cost, safer combatant craft. Okay, that's how we entered. But all the branches do this. Okay, and the cool thing about the Small Business Innovative Research Program is only small businesses can participate. All right, and so what does that mean? Okay, so that means this. A small business in the U.S. has to have less than 500 employees. You have to be 51% U.S. citizen, individually owned. Okay, so they don't want you to be controlled by any large corporation. You can't be too overly concentrated in one area too. If you have one customer that's doing 90% of your business, they're going to consider that controlling interest. Okay, so there's a few little rules, but in general, the easy rule is there's no dollar limit to be a small business. You got to have 500 or less employees, which includes all divisions, affiliations, and branches. The 51% U.S. citizen, individually owned, can be through a second tier. So you can have a parent company that's 51% owned, or a subsidiary that's 51% owned, as long as one of those two are doing it. Okay, and the way the program works, there are three-phase programs. So in the first phase, the branches differ a little bit depending on where we're going. But the first phase is $200,000 typically. And that's a 6-month level of effort. And we kind of look at that money as the basic work to help find the things, find the innovations that you're going to thrust forward in phase 2, where you get $1 million. So phase 1, 200,000, 6 months. Phase 2 is $1 million to a little over $1 million, depending on the program. That can go for a year. Okay, and then phase 3 is any money that is not the SBIR program money, any money. So the government SBIR program funds phase 1, phase 2. Some have phase 1A, B, C, which are extra fundings in there to help push technology along. Because, you know, if you're in the defense game, there's not that much you can do for $1 million, believe it or not. Actually, the boats are beautiful because we can make a big impact for $1 million. But when you look at systems and combat systems, you got to move the decimal point a couple points. So they've created these other bridge fundings within there to help move those along. But the objective is to get to phase 3. Phase 3 means you've developed technology with the government seed money, okay, America's Seed Fund, and now other people are giving you money. That other people can be commercial, it can be government, doesn't matter. It all counts. So you're judged on your phase 3. Your scorecard is your phase 3. Okay.
Hey, Scott,
Yeah, yeah.
who develops the scope of work for these different phases?
Yeah, awesome question. So the branches will do that themselves. Okay, but you can talk to them about it. Okay, so if you have something really cool, I've seen this happen, or the government sees something really cool at a trade show, they'll write a topic around it. Okay, I saw this really cool thing. This could really solve a problem. So they'll write this topic up, and then they'll call that company and go, hey, there's a Sbir topic, you might want to bid. Okay, and that's they can do that. I've seen it happen where it's happened, and the company that they saw with the idea isn't the one they picked. Once they put it out to bid, they found something better. All right, and so they're pretty competitive, the Sbirs, but it's really powerful. Here's why, right? It's the next bullet, because normal government contracts, other than this world of Sbirs, is the government gets to keep everything. Okay, in the Sbir world, they've created these special data rights and technology rights, and so the small business gets to keep the technology. The small business is encouraged to commercialize the technology. It's scored on how good it does. So it really is thinking about it like a seed fund. Okay, so you get to keep your data rights. There's another important part is your data rights live for 5 years past the end of your last phase 3. Okay, well, a phase 3 is anybody's money. Anybody's money. So it's very easy to keep these going for a very, very long time. You just got to remember to put your projects in, and you get extended, okay? And your rights extend. So that's one valuable part. The next one's even, I think, potentially more valuable. It's direct contract rights. So in the normal government contracting world, they've got to compete these things. These competitions can take a year and a half, 2 years. They take a long time. And the government guys, by the time they get through all that and award the money, it's like, the thrill's gone. If a small business has technology that meets the need, and it came from a Sbir, we have unlimited direct contract rights. That means these are already competed, whether it's a phase 1 or phase 1 and a phase 2. Okay, you get unlimited direct contract rights, which means the government can contract as much as they want without going through the traditional contracting source. They can direct contract you, sole source, for as much as the government wants to. That's the only catch, is the government has to want to. So you can't really make them want to. You can try, but that's it. So there are companies that get very, very significant recurring contracts from Sbirs. There's some really cool technology that's come out of Sbirs. It's really an amazing program. The one that comes to mind is the Da Vinci operating system, where surgeons are remotely operating. That has roots in an Army SBIR for field medics. So some of these technologies are really pervasive. And the other thing we're doing that's new is we're doing Sbir on Sbir. We're taking innovations from Sbir companies. Like in one case, we just did our transportation solution and married it with a refrigeration solution to combine 2 Sbir technologies to actually really leverage advantages. And so, that's another great opportunity. Okay. So what was happening here is, you're great. You got your phase 1, about 1 out of 10, 1 out of 15 proposals get phase 1 funding. Okay, give you a feel. 1 out of 2, 1 out of 3 get phase 2. So they're going to down select, from 10, maybe they'll pick 2 or 3. Phase 2, they're going to pick 1. Okay, and that one keeps going. At the end of phase 2, there's something they call it the Valley of Death, because it's like, oop, you're out. Program's over. They've created this 2A, 2B, 2C things to try to keep it going. But one of the better ones they've created that's worked really well for us is something called the Rapid Innovation Fund. And this program really kicked butt. It's a great program. It didn't get funded the last couple of years because of the way they are at the government, but we're pushing hard to get it refunded. And basically, this program would give you up to $3 million, 2 years, and requires you to team with your government partner. So it's really unique. So you develop this technology for the government. Now the government wants it, and now you and the government are going to fight against a bunch of other people that have cool technology, and you're going after a pot of funds. And we did score one of these, which are hard to get, but we did get one. And they could fund this probably 10 times more than they fund it, and it would still not be enough to just give you a feel for how much innovation is coming out of these programs. Okay, and so the case study is just that, right? We started out with SBIR, and you can look that number up there, on combatant craft, and they wanted a easier to build, easier to maintain, lighter weight, more affordable combatant craft. And so with our work we had done in the boating industry, we had done a lot of work with Prisma preforms and lightweight boats, done some work with ribs, and we've done some stunt boats for some of the theme parks. So we kind of threw all this together and came up with a concept to make a really lightweight shock mitigating boat. And kind of, you can see the construction of it here. It's not traditional, and it's basically like an aerospace-y kind of thing with a lot of thin framing, small section framing. Okay, did you guys lose the share? Or we have to?
Yep, there we go. We can see it now, Scott.
All right, roger that. See, I'm watching you guys. All right. So what we did is made really thin skins. I mean, really thin skins. A couple layers of 3610, layer mat, 2 layers 3610, Prisma frames, and made this very lightweight skeleton. And then on the deck of the boat, it's got very tall frames running transverse. So we decouple the hull and deck. So basically, the deck of this boat is only connected at the sides. It's literally floating over the hull bottom. And it takes weight out of the boat, as you can see here. This one of these prototypes we built, we're pulling about 40% of the weight out of the structure. But it made the ride really nice, decoupling the hull and deck, changing from this idea of rigid body construction, which is how boats are built. Every shock, every ripple goes right into your legs, into your body. These boats deflect a couple inches on big hits between the hull and deck, and it really makes a nice difference in the ride quality. So we're down this path, and we got fortunate. We got some money out of some phase 3 funding right at the end of phase 1. Before we got our phase 2, we got phase 3 funding from the Navy Composites Center out here. And at that time, they were just coming out with these alternate fuel outboards. So these are early Mercury JP fuel engine. You can't have gasoline on a ship; it's too dangerous, and so we've been stuck with these heavy diesels. And back in 2012, when we did this is the birth of the outboard heavy fuel engines that you'll later see in our RIF that we took to deployment with the Navy here. But the weight really attracted a lot of attention, and we had some early commercialization. You've seen that maybe with Hydrosport, where they took this skeleton design and used it in their 53 and 65. Now, we didn't want to do the suspended deck on a boat that big, but we did use that skeleton design and then landed a conventional stringer system on it, which made that boat very light. The Hydrosport 53 without engines weighs about the same as the 42 without engines, to give you a feel for the weight savings. Okay, and it costs more too. So on the journey, we'll go through the inventions we made, in particular CoCure. We were able to really rack up a lot of awards. That was helpful. And if you've been to the trade shows and stuff, we're there. And these helped kind of grow the buzz about the technology and started really helping on another mission that we've been pushing for a long time, is not to be dependent on just the marine market. We want to be in other markets, and it's been a long-term goal of the company, just because the boating industry's cycles are pretty deep, and I'm predicting we're probably coming into one here with gas prices where they are. So when you look at these other markets, and you look at the material acceptance, this is a little bit of old data, but I don't think it's changed tremendously. This is by Lucentel, I think in 2012, this data. But the marine market's about 68% penetrated with composites. So it's a very accepted material. There's no barriers to its use. It's widely accepted. When you look at transportation, though, it's about 4% penetrated with composites. When you look at construction, it's about 4% penetrated. So there's very little market penetration. What makes this really impactful is when you look at the size of the markets. Okay, so the marine market at $500 million, that's 68% of it. Well, gee, over 5 times the size of the marine market is 4%. About 7 times the size of the construction market of the composites marine market is 4%. So it really helped us focus in on our mission at the company to say, well, do I want to make this 68%, 75%, or would I be better serving the world if I can make 4%, 8%? Okay, well,
yeah, there's a lot of room to grow there.
A lot of room. So we were very fortunate that Wabash came around, and Wabash was really looking for innovation and collided with all that publicity. Remember all that PR we were doing, all the awards, all this stuff. It collided, and luckily they connected. They made the connection, and we had just what they needed. And we benchmarked Wabash at the beginning. They make 60,000 just the 53s. They make 60,000 of those a year. They bought their number 2 in truck bodies now. So they're a huge, multi-billion-dollar company. And just looking at the semi-trailers, if we put all those to composite, just the floor, let's say, which is a very viable option, the chassis, it's about the size of the marine composites market just at Wabash. Okay, that's one company. So that really, opened our eyes and kind of gives us our focus. So as we talk about these other markets, the kind of a little jive of what we're trying to do is we're trying to use the marine market as our technology development bed, and then use these bigger markets to upscale it even better and drive technology to deployment, right? And then bring it back around for the military. So as you could imagine, these are shock mitigating boats. So the boat's moving a whole bunch. There's a lot of motion. It's really like gel coat's worst nightmare. Okay, gel coat's really brittle. Boats are designed around the gel coat. Gel coat's elongation is about 1.5%. Our cheap resins stretch to 2.5%. Our high performance vinyl ester resins are 4 or 5%. We're not making the use of the materials that we could because of the coatings. Now you make a shock mitigating boat that flexes, and the coatings really aren't going to work. So I started on the journey back in 2009 with this, looking at polyureas. And if you remember us, we were doing something called shark skin, and I was looking at Line X, things like this to replace gel coat, and discovered its real Achilles heel is it's too flexible. And when it's so flexible like that, you get any kind of damage to it, it hydrodynamically peels. So I was right in my phase 1 going, I got a problem. And fortunately, we had gotten some extra money from the state of Florida. They had a Sbir Plus program that gave us some extra money. And I started playing with this marriage of polyester and polyurethane, and just literally stumbled onto this compatibility that I could take certain polyurethanes and certain polyesters and just literally mix them together, and they cure into like a new material. And it was really cool. And so I recognized what it was and what it could do very quickly, and talked to some experts, and they all said, no, you can't do that. It won't work. So that tells you go file a patent. So we filed a provisional patent on it and went on the journey with CoCure. And as you can imagine, so here you go to these big resin companies, in this case it's Interplastic, and you go, hey, I got the greatest thing in the world. I need you to stop everything and develop this technology for me. And oh, by the way, the Navy makes about 300 boats a year.
Right.
You're not getting a lot of love. All right. And so the magic here was the timing. So as we're doing this, Wabash is in here looking for the next big thing. And then when they kicked in the CoCure, they bought in before it was patent pending. It's patented now. Now all of a sudden the supply chain's falling all over themselves. Okay, what can we do for you? How much can we give? So millions and millions of dollars of product development. Okay, and the result is the finished product. There it is. So here's CoCure, and CoCure is really simple, right? It's your polyester resin, or gel coat or adhesive, whatever you want, putty, with its catalyst, and we're combining it with the A side and a B side polyurethane. They're all optimized to work with each other. Okay, but what's amazing about this is this entire profile is possible by just the blend of the 4 chemicals. So we're doing the chemistry, we're doing resin formulation on the factory floor and making radical changes in properties. And we're just changing ratios here. So here's the MVP gun that's set up for CoCure, and you can kind of see it's got your regular resin pump, it's got a catalyst pump, but it's got this big old slave arm system, and that's your polyurethane A and B side. So they've now got a 4-component gun that lets us change the ratio of any of these components. And excuse me, when we started on our journey, it was like, oh, elongation, that's what we're after. And so we learned, okay, we got stretchy urethane and rigid polyester, and if we put more stretchy stuff in, it gets stretchier. And this is the one of the early curves from a couple of years ago, and you can kind of see, take the urethane out. So we're really sophisticated here. So if we say CoCure 20, that's 20% urethane content. So that means 20% of the constituents are the A and B chemical. So if you go to CoCure 0, that's gel coat today with about a 1.4% elongation. Nothing much happens till you get to about 15% urethane. And then it starts really kicking in. Between 10 and 15, you'll notice you get a doubling of elongation. And this 15% is a real sweet spot. Is a real sweat spot because the urethane that we use is expensive. It's automotive grade aliphatic urethane. It's the stuff for cars. So the weather's really, really good, but it's more expensive than gel coat. And so the more you add, the better it weathers. But this spot right here gives you an elongation that matches the inexpensive resin and fibers. It's already 2.5% for the cheap resins. So that's kind of a good economic sweet spot. But you can go further. And back then we were in the 20, 25%, and you can see how much. At 20%, you could drive a forklift over it. Okay, at 25%, it's stretchy and it's becoming elastomeric. Okay, and so the idea is, yeah.
Scott, with the CoCure technology, so is the urethane and the polyester actually reacting together, or is it just curing at the same time and forming basically like a polymer network, if you will?
No, it's a great question. So it's a little bit of both, right? So there's some linking between the urethane and the polyester. Okay, and there's also a networking. So it's got actually some of both. So okay. If you look at, I didn't put the slide in for cutting it, but I actually, Interplastic made a slide that has all the molecules. And it is really interesting because the polyester are long chain noodles, like big long noodles in a bowl of soup, polyesters. And when they cure wherever the noodles touch, that's the way I kind of think about it, the way Scott Crump and Interplastic taught me here. That's where it freezes and becomes rigid. While polyurethanes are really small, teeny little molecules, and they group by chain extension. And when we mix them together, we're getting this hybridization between cross-linking and chain extension. And you can really see it's not a linear, it's a very non-linear behavior where it just all of a sudden it really goes. And I didn't mention, now we're doing stuff at CoCure 50, 60, 70, and it's pretty cool stuff. At that point, it's like really tactily, you can feel it. It's much more elongation, up around 100% elongation. Okay. And so what are you going to do with it? Well, like here. So now if I can change my properties ply by ply or spatially in the case of a coating, do I want the same coating properties on my leading edge or my trailing edge? Do I want the same bottom properties where I'm going to run aground, or on the top? Do I want more abrasion resistance? Do I want more impact resistance? Same thing. So now I can kind of dial this stuff in and out, and that's the coating side. But then on the resin side, there's a game to be had too, because I got glass fibers, carbon fibers, plastic fibers, and I use the same resin with all the fibers. Well, gee, maybe I could. What if I'm changing my resin properties as I'm changing fibers? And what if I'm changing fiber location and resin properties? So you start to get the idea. There's a lot of dimensions that, from a science point of view, this is kind of fun, because it's like 3D chess, right? You got a lot of new things you could do that you couldn't do before. And sometimes, especially with materials, now you'll see as we talk about hybrid composites, marrying materials with really different properties, different moduluses and stiffnesses, creates really good damping and noise reduction, and some opportunities in addition to lightweighting. Okay, and yeah, better to be lucky than smart, my lawyer always says. So it's just like, it's great. The more urethane you put in, the better the stuff gets. This is CoCure 15, and you can see in abrasion it's about double. Okay, if I go to CoCure 50, it's 10 times the abrasion resistance of gel coat. 10 times. Okay. CoCure 15 has about double the weathering of regular gel coat, gloss retention, color retention. And again, that goes up because you're pulling styrene out, putting polyurethane in that doesn't weather like the styrene does. And even at CoCure 10, 15, you're a low HAP material. So it's kind of neat. It bridges the EPA guidelines. And then, the other thing that we're really lucky on too is polyurethanes have, the A side is kind of nasty, right? The A side of polyurethanes have a lot of potential environmental health consequences. And it turns out these levels that we're using, the amount of ISO, the A side that we use is so small that all of the testing that's been done at numerous factories now, it's undetectable. So you're getting the low HAP and you're getting low ISO. So that was really fortunate for us. Okay. So at the seminar, I'm going to talk a little more about business models. So I'll leave a little bit of that for the session. But I wasn't happy with the business model, so we kind of created our own business model, and we'll talk about it. It's a technology sharing model, and Wabash is a part of that. So without getting too much into it, Wabash joined the company, became equity partners, and now technology we develop only can go to them. They are exclusive in their market segment. We can't deliver our technology to anybody else. But as we develop technology together, we're free to take the technology to other non-reserve markets. And so there's this whole new story of technology sharing, technology collaboration. And it just really, a good example are the aerospace companies. You can go to Boeing's got a lot of patents, Lockheed's got a lot of patents, and Boeing's patents are to keep Lockheed from doing stuff, and Lockheed's patents are to keep Boeing from doing stuff. But if I could take a Boeing patent and make a semi-trailer 30% more aerodynamic, does Boeing care? Okay, and so there's all this IP that's defensive IP that if we could figure out how to tap it, it could do good not only for the company, but it could do good for a lot of other things, good for our country. Okay, and so in the business model, I stole a lot from the Navy Composite Center, which I've been working with for 25 years, in their collaboration models. And in the early days, the big aerospace guys were paying like $250,000 a year to be a member of the Composite Center, and they'd place a guy on site. So I've got a Wabash guy on site, lives here, does work here. We do all the research. And one of the big inventions we made a couple of years ago together was that we're still on, is really cool. Is this journey of marrying metal and composite. And we made a discovery again with CoCure. And what we're trying to do is like get rid of the negatives of each material and stress the positives. Okay. And we discovered that the CoCure, now changing that formulation again, we can change it from a coating to an adhesive. And by making it change from not stick to stick, it can really stick. Okay, so we can spray it right onto metal surfaces, just like we'd spray gel coat, but now it's an adhesive coating. We spray it on the metal, and then just like laminating to gel coat, you laminate on the metal. That's it. It's just that simple. And you can kind of see here some of the first pieces we made. This was with a methacrylate, popped off. This is the hybrid metal one, and it bent. It took shape. Okay, and we went, oh. Me and the Wabash, Travis from Wabash, we were doing the Snoopy dance, because it was like, wow, automotive. We could stamp this stuff out. We're going to change the world. And so this is what we needed for Wabash too, because metals give a lot of toughness. They give a lot of point load. They give a lot of modulus. All right. Where modulus stiffness is expensive for composites. Glass is not a stiff material. Carbon's a very stiff material, but it's 10, 20 times the cost of glass. Okay. Aluminum, we can buy aluminum at $10 at $2 a pound, and it's got a 10 million modulus. So we can use aluminum just for its stiffness. We can use it to replace things like carbon and be very cost effective. Okay. In this case, we're doing semi-trailer floors. So in the Wabash's rapid innovation process, we went in about 7 months from idea to deployment. And so here you'll see larger scale tests that we did on a floor section with conventional adhesive. And then with the CoCure, we're punching through it. We're getting better loads. And from there, we got permission to build a prototype, which they full scale test. This is something they would never, ever do before. Pick a unmanufactured floor up by the ends. This was amazing to them, that it wouldn't just buckle without the walls sitting there. Okay.
Hey, Scott. So I got a question that we've got presented to us. So as a reinforcement resin, are the processing properties, gel time, viscosity, et cetera, are those suitable for LRTM, infusion, and other?
Absolutely. Yes. Yep. Absolutely.
Awesome.
So, yeah. It's the probably the one challenge with CoCure is if you need a really long gel time, you tend to get pushed to the aliphatics. The aromatics tend to go faster. So if it's fast, we can put you in that. If you need a really long gel time, the aromatics give you the time. It's just they're so much more expensive. The aliphatics are so much more expensive. But yes, absolutely. Pretty much. And as you'll see now, that's where I'm doing in another SBIR. We're actually pushing that. I'll talk briefly about it here. So here we go, right? We got this money. Wabash came along, came commercial. We've been plugging for Rapid Innovation Fund. They get 2,000 white papers. They fund 11 projects. Okay, so the third time I finally hit it. I came back and we had gotten far enough and we won on the third one. Well, it's because we'd come a long way with CoCure and everything else, and we had commercial products. We had a good story. We married the CoCure technology to the emerging outboard engines, which the Navy is really keen on. So we had Mercury, Evinrude, Cox, Ox, engines from all over the country, marrying them up on the boats. And this is a great contract. So we built boats, instrumented them, built them at the OEMs that are making it. So we built boats at Brunswick, at Zodiac, at Willard, at United States Marine. We're going to the supply chain the Navy uses so that they can pick it up and deploy it. Okay. And then we'd instrument it, test it, and deliver it to the Navy. And that kind of was our Rapid Innovation Fund. So, the point of this is this leveraging between the two is very, very powerful. I think it's good for both the commercial side and the government side, because with the government, we don't have the volumes we need to push cool innovations. And then once this becomes commercial, now it becomes deployable and affordable for the government to be able to buy it, and it's out there. So this was one of the boats that we delivered to the Navy, and this is the 7 meter standard Navy rib. We started out at 5,600 pounds when we were in a Gen 1 craft. We came in at 3,500 pounds. Okay, dual engine. You could tilt up one of these engines and it runs pretty much like the old boat. Okay, twin engine. We blow every objective threshold out of the water. In fact, the things that happened between 2012 and here is interesting. And in 2012, we didn't have digital control. And that first boat I built, I loved it because it would go 72 miles an hour. But the Navy didn't like that at all. And the problem is if you got 2 guys in the boat, it goes 72 miles an hour. If you put 25 guys in gear, it goes 40 miles an hour. So it's not really a good solution to that until today with digital control. So this boat at 50 miles an hour, that's it. It uses speed and they set the digital parameters. So, if it's two guys in it, that's happening at half throttle. And if it's full loaded, you get more throttle. So that technology really helps improve the safety because we took that first boat out and let the guys try it, and every single one just wanted to see how fast they could go. So without fear. So it was a pretty, with a great grin on their face, of course.
I bet.
Using that model, you might have seen at CAMX, we did a 72-foot reefer car. This uses the CoCure technology we developed with from the Navy, now with Wabash enhanced. It's a metal hybrid. Now really thrusting us into rail. We have a lot of rail projects that are going to be on the horizon. Working with Trinity as our partner in rail. So we have a similar arrangement with them that we're just working with Trinity on an exclusive basis. And we'll talk about that next week. And then we won a Sbir, another Sbir. Okay, so we won this last year, and this is titled Game-Changing CoCure Coating Resin and Adhesive Technology for Automotive. We're teamed with Ford, and we're in the phase 1 process now, and getting some really nice results. It's like my little metal piece. I got metal shapeable composites. Well, you'll be seeing this, things you could form with metals that are really cool. We're really excited about. And we'll be writing our phase 2 proposal, be going into the next cycle next year on that one, and trying to get $1 million there for the phase. Okay. And then if you didn't see it, the CoCure also impacted our work in infrastructure. We've been working composites and infrastructure since we started almost in 2000. And it's always been a lot of challenges with price acceptance and materials, but we've stuck with it. We believed it's going to happen. And CoCure's economics really helped the bridge project. And so last year during COVID, we did a composite bridge with Iacme and the University of Tennessee and Composite Application Group and a whole bunch of supply chain partners. Everybody, we put this bridge in for free for a poor rural community in Tennessee, 100% free. And we did it all, and it was great. I'll tell you that people really like you when you put a bridge in for free. They don't complain if you're late a week or anything. So it worked out good. It's really neat if you're up there, or Acme's featured it. But what's cool is it's got fiber optic sensors from Luna Technologies embedded in there. These panels, okay, they're 25-foot wide bridge, and the bridge is 16 feet, so it's just 2 modules. And what we're trying to do is we're trying to prove out our bridge deck. We had gotten through all the DOT testing and labs, independent testing, everybody had done, funded by DOT, but we hadn't been fielded. And we're not going to get anywhere until we're fielded. We can't be shovel ready. So we decided to do this with the PPP money, and we all kicked in, and we're going after highway bridge decks. And lo and behold, we figured out, oh man, there's a real opportunity on these rural bridges. This bridge deck, these 2 composite modules, they weigh 4,500 pounds each, pick up by a forklift. So you can see these also on a trailer. And the need for small community bridges is off the charts. There are many, many, many bridges right there in that area of Tennessee that when you're just driving over them and you look at pictures from underneath, you go, oh no, this ain't good. Okay. And so the community we did this with wants a bunch more. Georgia wants some. So we're in that bit part right now, figuring out how to move to the next stages and the right partners to start growing this. But we really want this to be part of the infrastructure solution, which would be great. And putting the smart structures in there and sensors really helps. And if you look here, it has its own, so you can go on that website and watch Insomnia. You can watch 24/7, a live feed of the. But as vehicles are going over, all those sensors are reading. Okay. Here's the chancellor speaking.
Of why we need brilliant engineers, future brilliant engineers, to all the students who are part of this, to make life and lives better.
So you can kind of see the before and after here. Okay, and one of the neat things about this bridge deck approach is you can make it a whole bunch of manufacturing processes. You can do it open mold, closed mold, high volume, low volume. So for this one, we just did a wet layup, which made it really easy, and built it real quick, and it's been in there for over a year now, so it's doing really good. Okay. So, yeah, hopefully it won't end. So that's our mission. Is what I'm trying to do here in the company. Been at it for a while. We're working hard on succession, next generation, but we really want to be a technology feed for the country, for the world, continuing to generate technology. We've got a good model that we've given up on. We're not going to scale these up. Why would we do that? We let our partners do the scale up, and we do the technology. And I think that marriage is working really good, and it works to the benefit of everybody, and it lets us do what we're good at, and it lets them do what they're good at. So with that, I'll take any questions.
Yeah, that's great. If there are any questions, please put those in the chat, and we'll get Scott to answer those. I think it's very interesting to see how the technology can transfer from one industry to the other. Like you pointed out, Scott, there's tons of room for composites to grow in those other industries, transportation and infrastructure, where they've barely scratched the surface.
Yeah, definitely. Yeah. One question that we've gotten, Scott, what are some hurdles that might not be expected with the SBIR application process itself?
Yeah, sure. Yeah. So, one of the unfortunate things that when the Sbirs came out, our very first thing, one of the first monies we got was an SBIR back in 1987. And they were really built for the small business, having never done any work in the government before. They're super friendly to you didn't need to have much of anything. Okay. Unfortunately, that's changed a bit now because it's not the requirements like a big defense contractor, but you got more to deal with than you had to before. All right. So depending on the work you're doing, if you're picking a topic that's ITAR, which means International Arms and Trafficking Regulations, you'll need to be an ITAR certified company. Okay. Which means you got to give them about $5,000 a year and fill out paperwork and be registered. And if you give the information away, you go to jail for life, something like that. Right. So it's pretty serious. So when the topics come out, if it's ITAR, it'll say it. Okay. And Kevin, the other thing is there's an open period. Okay. So what you want to do is go to DOD-SBIR.net, I believe it is. So just DOD-SBIR, look that up on Google. There'll be a website and it'll list all the dates that these come out. And then they're gonna come out in what's called a pre-publication listing. All right, so they'll have like 2 to 3 weeks. It's not officially listed. They're out in pre-publication, and a lot of the topics will have the point of contact there. They want you to call them. They want you to talk to them. Okay, and if they do, it's there you go. Thank you. And if they do want you to talk to them, because it could help do two things. One is if you have something that's really off base, you're not wasting your time. Okay. Secondly, when you do put a proposal in, they're going to remember this conversation you had. And third, in this open conversation, they can answer a lot of questions. Once it officially publishes, they can't talk to you anymore. All right. You can submit a question. That question is going to get answered and published to everybody. All right. So, there's a couple pointers there. The other thing I'll say is there's a tremendous amount of help resources to get started in the SBIR program. So if you go to that website, if you go to your local community, there's probably workshops, there's companies that will help you with the proposal writing. They may be subsidized by your state. There's a lot more being done here than you know. And then when you win, right, like depending on the branch, the Department of Energy one that we just won, they have business enhancement money that comes in your phase one. Okay, it's on top. They're not giving you extra money. You still got your work to do, but they're giving you access to business experts to help you refine your business model, refine your approach, and you're getting, I would say about, in the phase one, probably $20,000 of coaching from professionals who do that. That's what they do. In phase two, you can get 50, 60,000 of third-party coaching. That's not coming out of your budget to help you move it along. So there's a tremendous amount there, and the Sbir's aren't just limited to composites. I mean, they're everything. There's health and human resources. There's every branch from nuclear, the defense, Department of Transportation, Department of Commerce. Everybody's got them. Okay, so if that helps. Are there any specific you can reveal about the Ford? Yeah, sure. So on the SBIR, it's kind of cool, right? So it's really nice being in the industry for a while because you get it's kind of like bell bottoms. You watch everything go around in circles, or in the case of me and James, beards come back in style. You've heard like out of autoclave, right? You've heard of additive manufacturing. Well, for us building our stuff, we've always been out of autoclave, and we've always been additive. It's just people. Or the guy with a chopper gun, now it's a robot. Oh, that's additive. Okay. Okay, when you look at the automotive world, the thing that's really hampered composites from getting in there is the paint booth. All right, it's like the worst torture your composite's going to go through. And so there's this whole cool thing emerging that just like really neat for us and us as an industry is this out of paint booth composites. Okay, I haven't made an acronym, OOPB. OOPBC, right? But out of paint booth composites, right? So in the case of our project, what we're looking to do is we're targeting a platform like the Ford Transit van, an electrified platform, and they want to customize these things. They want to make them much more ready for the mission. So picture one that you could buy. It's like a TV version, TV station. It's got all the framing, mounting, and you just plug in your antenna. They got another one that's the plumber version, another one that's this, that, and the interior is all customized and outfitted, purposely built, but the volumes are going to be a lot lower. And, in their world, low volumes like 20,000 units. That's low volume. So the mission here is, picture the front end of this vehicle coming out of the paint booth, okay, high volume, and now marrying into this whole new opportunity zone of lower volume, more specified, certainly can have high volume ones too, but lower volume, specialized components that can give them a better customer experience. And that's really what they're about. They're big on customer experience. It's everything, a customer experience. Okay, so if we can make a better customer experience, they'll buy it. And so the challenge here is really a couple. One is like, if you remember, for the guys older here, cars from the 80s, we had the hard tops and they had that color on the black, the car would fade. So you could always tell like the hard top would look terrible and it would fade differently from the rest of the car. Or even some of the early composites, right? The body panels would fade differently. So one of the real challenges we're trying to do on the Sbir is say, okay, can I, with the CoCure technology, make a coating system that's an in-mold coating, and can I make it weather the same as automotive paint? And by the same, I mean like the same, like right through the whole profile. How far can we go? So it doesn't look funny. So that's a pretty tall order. Okay.
Fascinating. Seriously.
Yeah.
I think something that I don't even think I realized coming into this tech talk is honestly the fantastic advice and guidance that this is going to be able to provide the small business owner, the small company that's just getting into the industry. Awesome information. Seriously. Thank you once again, Scott, for joining us. We're really looking forward to next week.
Yeah, sure. And join in. I think they can join virtually too, or is it going to be all only in person? How are you doing it?
Yeah, I think right now we're just in person. We're going to see if we can set up a streaming arrangement. But can you just give us a quick bit about what you're going to talk about at the workshop next week?
Yeah. So I'll bring these technologies in again, but I really want to talk about the business model a little bit, especially for both big and small business, how big business and small businesses can work together and collaborate together. And I'll lay out my business model, let everybody see it, and talk about how it's working. It's a good business model because when I came up with it, all the business guys said I would never be able to do it.
Yeah, I can't wait to hear more about it.
That's my criteria for something good.
Yeah. So where can people reach out to you, Scott?
Sure, sure. So you could get me at slewit, SLEWIT, at structuralcomposites.com.
Okay. All right. Well, we thank you for joining us today on Composites Tech Talks, and let us know, if there are any other topics. We'll be having more tech talks throughout the year. Just let us know in the chat any topics or guest speakers you'd like to see. Tyler, you have anything for us?
Looking forward to next time, and also hopefully, if you haven't yet, register for next week's in-person workshop. Like James mentioned, 2 years since we've had ourselves an in-person, so looking forward to it. It'll be a good time. Awesome.
Right,
Thanks everybody.
Thanks, everyone.
Have a great afternoon.